This is Seek and Explain. Like, comment, and subscribe, and enjoy your stay.
You know, usually when we talk about exploring our world, there is this underlying expectation of visibility.
Yeah,
right?
absolutely.
Like you climb a mountain or you map the borders, you photograph a coastline, and, well, the landscape is known to you.
It's conquered, essentially. You know, the blank spots on the map are filled in.
Right. But point your finger straight down into the dirt, and suddenly that map is, it's just entirely useless.
Oh, completely.
The geographical landscape beneath our feet is completely hidden. It is this massive, planetary-scale black box.
Which is exactly why, for centuries, human imagination just rushed in to fill that void.
Yeah.
Because when we can't see something, we tend to invent these incredibly elaborate structures to explain it.
So true. And that is exactly what we're doing for you today. Welcome to this deep dive into the Hollow Earth theory.
It's a fun one.
It really is. And we aren't just looking at this as some, modern internet curiosity.
Oh, definitely not.
We've got a whole stack of materials here. We're pulling from historical Wikipedia articles, hard geological data from Iris and McGill University, and even some pop culture databases.
Yeah, it's a huge mix of sources.
And our mission today is really to shortcut your path to being totally well-informed on this. We're exploring how a 17th century scientific hypothesis devolved into this fringe conspiracy, birthed a whole genre of subterranean fiction, and ultimately highlights the incredible reality of our planet's actual core.
Yeah, and we're going to explore not just what people believed about the Earth's interior, but really why they believed it and, how our understanding has evolved over time.
Okay, let's unpack this, because to start, we really have to look back to 1692.
Right, the very beginning.
Because the Hollow Earth wasn't initially pitched by, some conspiracy theorist in a basement. It was proposed by Edmond Halley.
Yes.
Like the Halley's Comet guy.
Exactly, a peer of Isaac Newton. A highly respected astronomer.
Yeah.
And he stood up and proposed that the Earth wasn't a solid ball of rock, but rather an outer hollow shell that was roughly 500 miles thick.
500 miles thick. And inside that shell, he pictured two more inner concentric shells, and then finally a solid innermost core, just all floating in empty space.
Yeah, it's wild.
It's essentially a giant planetary matryoshka nesting doll.
That's a perfect way to describe it, with atmosphere separating every single layer, right? And all of them rotating at entirely different speeds.
Wow.
Halley even envisioned the interior gas between these nested shells as luminous, like it was glowing.
Wait, glowing gas inside the Earth?
Yeah. He actually speculated that when this internal glowing atmosphere occasionally escaped through, fractures in the crust, it drifted up into the sky and caused the aurora borealis.
Wait, hold on. A brilliant astronomer looks at the northern lights and mathematically concludes it's, glowing gas leaking from a hollow planet.
I know.
How does a mind like that jump to such a massive structural conclusion?
Well, what's fascinating here is that he was actually practicing good scientific method.
Really? By inventing a hollow Earth?
Yeah, because he was trying to solve a very real, pressing data problem using the best physics of his day.
Okay.
See, Halley was studying anomalous compass readings. The magnetic poles seem to wander.
Oh, right. They shift.
Exactly. Sometimes a compass would point slightly differently than it did decades prior, which, was a terrifying problem for global naval navigation back then.
Oh, sure. You'd get completely lost at sea.
Right. So to explain a shifting magnetic field, Halley realized he needed moving parts inside the Earth. A static rock wouldn't cause shifting magnetism.
Okay, moving parts make sense for a shifting magnetic field. I get that. But why jump to a hollow shell? Why not just moving rock or fluid?
And this is where Isaac Newton comes into play.
Oh, boy.
Halley based his planetary model heavily on Newton's calculations. Newton had recently published estimates on the relative densities of planetary bodies. But he made this critical mathematical error when calculated the density of the moon.
Oh, no kidding.
Yeah, Newton estimated the moon's density to be almost double that of the Earth, about 9/5 to be exact.
Wait, so Halley looks at Newton's math, sees that the Earth is somehow vastly less dense than a barren rock like the moon, and deduces there physically has to be a bunch of empty space inside of it.
Precisely.
That is amazing.
If you trusted Newton's math at the time, the Earth literally could not be solid rock. It mathematically had to be hollow to account for that low mass.
Right, right.
So Halley was practicing excellent scientific deduction. He just had deeply flawed ingredients. He needed a mechanism for wandering magnetic poles and a structure that accommodated a low overall density.
And the concentric nesting dolls answered both problems perfectly.
Exactly.
The irony is that science eventually self-corrected, Like, we figured out the actual mass and density of the Earth, we realized the moon isn't twice as dense, and Halley's model was abandoned by astronomers.
And the math got fixed.
But the idea itself didn't die with the bad math, it just sort of moved from the observatory out to the public square.
Yeah, it transitioned from a flawed hypothesis into just aggressive pseudoscience.
Here's where it gets really interesting, because by the 19th century, the Hollow Earth finds its most dedicated champion in an American Army officer named John Cleves Symmes Jr.
Yes, Symmes.
Right, so in 1818, Symmes throws out Halley's inner shells entirely and instead campaigns heavily for what people started calling Symmes holes.
Such a great name.
He argued there were massive openings at the poles leading straight into an inhabitable, sunlit interior. I mean, he claimed the North Pole opening was 2,300 miles wide, and the South Pole opening was 1,400 miles wide.
And he was completely convinced that if you just sailed far enough north or south, the ocean would just curve gently inward.
Right.
You'd sail right into the interior of the planet where the climate was supposedly tropical without even realizing you had crossed an edge.
He was so serious about this that he actually pitched the United States Congress to fund a federal expedition.
He really did.
I mean, imagine someone trying to secure taxpayer funding today to sail a ship into a giant planetary sinkhole.
It's absurd.
And people bought into it.
Yeah.
If you go to Hamilton, Ohio today, and we have the coordinates here, it's north 39 degrees, 23.71 minutes west, 84 degrees, 33.699 minutes. There is a physical stone monument dedicated to him, topped with a hollowed-out globe.
Yeah, Saylor's impassioned speeches really laid the groundwork for decades of polar hole theories.
Decades.
Because by 1906, you have authors like William Reed publishing books like Phantom of the Poles.
Oh, I saw that in the notes.
Yeah, Reed argued these massive polar holes were the logical explanation for all sorts of anecdotal Arctic mysteries. He claimed that things like inexplicably colored snow in the Arctic or sudden massive tidal waves were caused by debris and water just violently rushing out of the Earth's interior through these Symmes holes.
Wow. And that builds straight into the mid-20th century with the Admiral Richard Byrd conspiracy, right?
Oh, definitely.
Where believers claim that in 1947, Byrd flew a plane over the North Pole, accidentally dipped into the Hollow Earth, met an advanced civilization, and the government immediately classified his journal to hide the truth.
Right, but the primary problem for all of these polar theories was just simple geographic reality.
Yeah.
The final nail in the coffin wasn't some physics equation, it was explorers actually walking there.
Right.
In December 1911, Roald Amundsen undisputedly reached the South Pole. He stood on solid ice at the exact coordinates where Symmes insisted a 1,400-mile-wide abyss should be.
Just miles of freezing, relentless ice, no hole, no gentle curve into a tropical interior.
Exactly. And it perfectly illustrates how compelling a hidden world narrative can be for people. I mean, even when direct physical exploration completely invalidates a concept, people will still construct elaborate government cover-ups to keep the fantasy alive.
Because it's a better story.
Precisely. A
Yes.
secret subterranean utopia is simply much more appealing to the human psyche than a barren frozen ice cap.
So true. But once the surface maps were finally filled in and the poles were definitively conquered, that fantasy had to find a new home.
Right.
And it did. It birthed the entire subgenre of subterranean fiction.
Because storytellers needed a new frontier. Once we knew what was on every continent, the only place left to hide a lost world was straight down.
Exactly. And Jules Verne kicks this into high gear in 1864 with Journey to the Center of the Earth.
A classic.
Though interestingly, his characters don't even get close to the center. They only descend about 87 miles deep.
Which is practically nothing on a planetary scale.
Right. But they still discover a massive cavern the size of Europe, complete with an underground sea and prehistoric creatures.
And then Edgar Rice Burroughs pushes the concept much further in 1914 with his Pellucidar series.
Because I love Pellucidar.
Yeah, because you can't just casually walk into a cavern and end up deep in the earth. Burroughs had to invent the iron mole.
Yes.
This massive mechanical drill to violently bore his characters 500 miles down.
And Burroughs' world building in Pellucidar is just wild. He imagined an inner world lit by a constant noonday inner sun floating in the center. And he included a tiny geostationary moon orbiting that inner sun. And because the moon never moves relative to the surface, it creates this permanent eclipse on the ground directly beneath it, a region he dramatically called the Land of Awful Shadow.
It's incredibly creative, and the trope has just proven to be immortal. It is a foundational sandbox for modern sci-fi.
We see it everywhere, like the Godzilla MonsterVerse films use the Hollow Earth as the entire ancestral home for the Titans.
Oh, right. Yeah.
In Godzilla vs. Kong, that corporation, Apex Cybernetics, literally has to build specialized crafts called HEAVs just to survive the intense reverse gravity fields required to enter that subterranean world.
And it's heavily featured in gaming, too.
Oh.
The massive 2015 indie game Undertale operates entirely on this premise.
Yeah.
The player falls into a sealed underground realm populated by monsters who were banished from the surface world by humanity long ago.
It's like the Hollow Earth is right up there with zombies or time travel. But it feels like a very specific psychological craving, you know? Why are we so obsessed with underground worlds? Why do we constantly want to imagine fully formed, thriving worlds hiding beneath our basements?
I think it serves as an isolated canvas.
How so?
The Hollow Earth allows storytellers to explore utopian fantasies, ancient horrors, or deeply alien societal structures, but entirely cut off from human history.
Oh.
You don't have to invent faster-than-light travel to another solar system to find aliens. You just dig down. It is the ultimate hidden room in the House of Earth.
That makes total sense. But Burroughs having to invent an iron mold drill to get his characters down there really highlights a brutal reality. The Earth's crust is aggressively hostile to us.
Very.
We've talked about what we imagine is down there, but discovering the actual geology requires bypassing some insane physical limitations.
Yeah, our physical reach is astoundingly shallow. I mean, the deepest humans have ever managed to drill into the planet is the Kola super deep borehole in Russia.
Right, that was a massive Cold War inner space race project.
Yes, and despite years and years of drilling, they only reached a vertical depth of about 12 kilometers.
12
That
kilometers.
is roughly 7.5 miles.
And the distance to the center of the Earth is nearly 6,400 kilometers.
Exactly.
12 kilometers is barely scratching the paint on the surface. Wait, so if we've only ever physically poked a 12-kilometer hole into a 6,400-kilometer planet, how are geologists so intensely confident about the exact composition of the core?
Well, we use seismology. We rely on the unimaginable energy released by massive earthquakes, like the 1994 magnitude 6.9 Northridge earthquake in California.
Okay.
When a seismic event like that happens, it sends energy outward in massive waves, ricocheting through the entire interior of the planet.
So seismology is basically like a planetary medical ultrasound.
That's a great way to put it.
We're just using earthquake waves instead of sound waves to map the hidden tissues and bones of the Earth.
That is the exact mechanism.
Yeah.
Earthquakes generate different types of seismic waves, and the two most important for mapping the interior are P waves, which are compressional, and S waves, which are shear waves.
Okay.
Observatories all over the world record how fast these waves travel and exactly where they arrive on the surface.
Let's break down the physics of that for a second. How do these specific waves prove what's at the center?
It all comes down to shear strength.
Shear strength.
Right. S waves, the shear waves, move with a side-to-side motion. Think of shear strength as the ability of a material to snap back into place when bent.
Like a ruler.
Yeah, exactly.
Yeah.
Solid rock has shear strength. It can vibrate side to side and pass that wave energy along to the next rock. Liquids, however, do not have shear strength.
Okay.
If you push a pool of water to the side, it just flows out of the way. It doesn't snap back into a rigid position.
Oh, I see. So an S wave simply desiccates the moment it hits liquid.
Exactly. And when a massive earthquake happens, we observe that S waves never arrive on the completely opposite side of the Earth. They hit a massive boundary deep down and just vanish,
Wow.
which completely proves that we have a massive layer of liquid inside the Earth. It's the outer core, this 2,200-kilometer thick churning ocean of molten iron and nickel.
Okay, so that proves the liquid part. But what about the solid inner core? Because Halley pictured a solid sphere floating in the middle. How do we know he was partially right about that shape?
That is where the P waves are crucial. P waves compress and expand matter, pushing back and forth like a slinky.
Okay, got it.
They can travel through liquids, but when they transition from a solid to a liquid, their speed changes and they refract. They bend, much like light bends when it hits a glass prism.
Oh, so when these P waves hit that liquid outer core we just talked about, their path gets deeply distorted.
Yes. They bend so sharply that they create a massive shadow zone on the Earth's surface.
A shadow zone.
Yeah, it's an area between 100 and 140 degrees away from the earthquake's epicenter, where almost no direct P waves are detected by seismographs.
Oh, wow.
But they do reemerge on the very far side of that shadow zone. And the specific timing and angles of how they reemerge prove that they hit something dense and solid inside that liquid.
They hit an inner core.
They hit an inner core.
A solid, iron-rich metal orb, bigger than the entire planet Mercury.
Sitting under 3 million times the pressure of the surface.
That is insane.
And that intense, crushing gravity forces the metal into a solid state, even though the temperature down there is nearly as hot as the surface of the sun.
That is just staggering to think about. An orb bigger than Mercury, as hot as the sun, sitting about 4,000 miles straight down. That core is physically closer to your feet right now than Los Angeles is to New York.
Yeah. And if we connect this to the bigger picture, it isn't just a stationary dead rock down there.
No.
The interaction between the solid inner core and the churning liquid outer core is what keeps our planet habitable. This movement creates a geodynamo effect.
Okay, explain the mechanics of that geodynamo. How does moving liquid metal generate a magnetic field?
Well, because molten iron and nickel are electrically conductive fluids. As the Earth spins, the liquid outer core churns in violent convection currents, driven by the intense heat escaping from the solid inner core below it.
Okay.
In physics, moving a conductive fluid creates electrical currents, and those massive electrical currents generate a massive magnetic field.
Wait, the exact same magnetic field that was messing with Edmond Halley's compasses?
Yes, exactly.
Oh, that is so cool.
And that magnetic field extends far out into space, acting as an invisible shield around the planet. It deflects the solar wind, which is a constant, deadly stream of highly charged particles blasted out by our sun at 250 miles per second.
Wow.
Without that magnetic field generated by our heavy, churning core, those solar winds would strip our atmosphere away entirely. Earth would be a barren wasteland like Mars.
The irony is just incredible. Halley was looking at shifting compasses, trying to mathematically just justify a hollow void. He completely misunderstood the empty space, but he was actually right about a planet-sized core acting as the magnetic engine.
He really was.
It's not a hollow void of glowing gas. It's a densely packed furnace of molten metal.
Yeah, Halley had the right intuition regarding the necessity of internal motion to create magnetism, but the completely wrong physical medium.
It is such a phenomenal scientific journey. We start with Edmond Halley's Matryoshka doll Earth, born from Isaac Newton's bad density math.
Right.
We watch that morph into John Cleves Symmes Jr.'s doomed public crusade for giant polar holes. And when the map proves Symmes wrong, the imagination takes over, giving us Jules Verne's prehistoric oceans, Edgar Rice Burroughs' Iron Mole, and Godzilla's ancestral home.
All of which finally gives way to the geological reality mapped by the planetary ultrasound of earthquakes.
So what does this all mean? Since we physically cannot travel 4,000 miles straight down to see this magnetic engine for ourselves, how are we continuing to study it today?
Well, that brings us to one final awe-inspiring detail from the research.
Yeah.
Human ingenuity is actually trying to bring the center of the Earth to the surface.
Really?
Right now, scientists at the University of Wisconsin are actively trying to model our planet's magnetic dynamo in a laboratory setting.
Wait, how do you even begin to model a planet's liquid core in a lab?
By bottling plasma heated to 500,000 degrees inside a 10-foot wide spherical aluminum chamber.
You're kidding.
No, they use incredibly strong magnetic fields to try and mimic the fluid flows of the outer core. They are attempting to recreate the exact electrical currents that generate our planet's shield, to understand the physics of it up close.
So they are trying to build a miniature 500,000-degree Earth core in Wisconsin.
Basically, yes.
That is both terrifying and brilliant. It really reframes how we think about the ground we walk on. You know, I mean, the search for a mythical hollow Earth and its fictional inner sun eventually led us to realize we actually have a miniature sun made of iron right beneath our feet. And that dense, churning core is the only reason we are protected from the actual sun long enough to dream up these fictions in the first place. The reality really is profoundly wilder than the fiction.
This is Seek and Explain. Like, comment, and subscribe, and enjoy